Okay, so this is for number 4. It's pretty complicated, so everyone try and stay with me here. And they want us to solve this using integration by parts. So we want to try and find a dv, and we want to identify our u. So dv should always be the most complicated thing in the integral. So we're going to go with the radical x minus 5. And you always want to make sure you put the dx with the dv. And whatever's left over is equal u, so we're going to make x squared be u. We can solve for du pretty easily. We just take the derivative of u, so it's just going to be 2x dx. And for dv, we want to go ahead and find v from there. So we can integrate dv in order to get v. So v is going to be the integral of x minus 5 dx. And in order to integrate this, we have to do u substitution, but because we have a lot of u's and v's going on, I'm just going to do a substitution. So we're going to make a equal to x minus 5, what's under the radical, and then dA, the derivative of that, the derivative of x is going to be dx, and the derivative of 5 goes away. So dA is just going to be dx. So v is the integral of radical a dA, and we can rewrite that as a to the 1/2 dA. And then when we integrate this, all we're going to do is increase the exponent by 1, so it's going to become a to the 3/2, and we put a 2/3 out in front here. We're not going to put a plus c because we're just going to add that for our final answer at the very end, so we don't have to worry about the plus c until later. Okay, so right now we've identified our v. We want to go ahead and put this in terms of x. We want to make sure. So we can make this x minus 5 3/2, because remember a was equal to x minus 5 from up here. Alright, so now we've identified our v, we've identified our dv, we've identified our u, and we've identified our du. So when we do integration by parts, the formula that we want to use is u times v minus the integral of v du. So we want to go ahead and plug in all these parts into this formula here. So u is going to be x squared, v is here, so we have x squared times 2/3 x minus 5 to the 3/2 minus the integral of v again, 2/3 x minus 5 to the 3/2, and times du, so du is this 2x dx here. So all I've done is from here, I've identified my dv, my u, my du, and my v, and then I've gone ahead and plugged it into here. Alright, so now from this point here, I'm going to try and make this integral a little bit easier to work with. So I'm going to multiply this 2/3 by this 2, and that's going to get me 4/3, and I'm just going to pull that out in front. So this part is still going to stay the same. And I'm going to have a 4/3 out in front here, and the x minus 5 is still going to be there, the x is still going to be there, and the dx. Alright, so now from this point here, we want our final answer to not have any integrals in it, and this integral is still here. So we're going to want to go ahead and try and simplify this integral a little bit. So down here is going to be my final answer, and I'm going to add to that in a minute. So in this parentheses here, I'm going to leave this open for now. I'm going to put whatever we simplify this integral to be. So I'm going to go ahead and solve this integral all the way up here. So we have x minus 5, whoops, sorry about that, that's a 5, to the 3/2 times x dx. So whatever we solve this integral to be is going to go in this set of parentheses here. We'll close the parentheses plus c, and this whole thing will be our final answer. There's a lot of steps, so we just kind of want to make sure we're all following. Okay, so now from this point here, to evaluate this integral, we have to do integration by parts again. So you just want to keep track of your different v's and your du's and stuff like that. So I kind of just separate my paper here. So dv, again, is going to be the most complicated thing. So we're going to make that the x minus 5 to the 3/2 dx. So then our u is whatever's left over, and it's just going to be x. So our du is the derivative of x. It's going to be dx. So that part was easy. And then here, this guy, to solve for v, we want to integrate dv. So that's going to be the integral of x minus 5 to the 3/2 dx. And to integrate this, we have to do u substitution again. I'm going to do s substitution this time, just so that we don't get all our variables mixed up. So I'm going to make what's inside here be equal to s, and then ds is going to be the integral of this, the derivative of this is just going to be dx. Okay, so all we're doing here is trying to evaluate this integral to get v for our second integration by parts. So now we can plug in s, so it's going to be s to the 3/2 ds, and when we integrate that we get s to the 5/2 times 2/5, and again we're not going to put that plus c because we'll just add it at the end. And we want to make sure when we integrate, when we do u substitution, or s substitution in this case, you want to make sure you're always back in terms of x. So instead of writing s here, I'm going to plug in x minus 5 in again. So we have 2/5 x minus 5 to the 5/2. And this is our v from our second integration by parts. So I'm just going to put boxes around these. So we have here, we have our dv, we have our u, and we have our du. So we want to do integration by parts again. So we have all of our parts, and now we just want to put it into this formula. So we have u, which is x, times v, which is 2/5 times x minus 5 to the 5/2, minus the integral of v, which is here again. So 2/5 times x minus 5 to the 5/2 times du, which is just dx. So here, I'm going to just pull this 2/5 out in front. This part's going to stay the same. We pulled the 2/5 out in front. The integral of x minus 5 to the 5/2 dx. Alright, so this is our last integral that we want to get rid of, and then we'll be down to our final answer. So to evaluate this one, we're going to have to do u substitution again. I'm running out of letters here. I guess we'll do b substitution. So we'll make b equal to what's inside here, x minus 5, and then db is going to be the derivative of this. It's going to be dx. So this integral here, I'm just going to focus on the integral and leave this 2/5 here for now. So this integral is going to become the integral of, instead of x minus 5, we'll write b to the 5/2 db. And then from there, that's supposed to be an equal sign. From there we can integrate it, so we get b to the 7/2 times 2/7. And remember, we want to always write it in terms of x. Okay, so this was only the integral, but remember we still have that 2/5 out front. So really, if we bring this down, we have 2/5 times 2/7 x minus 5 to the 7/2. There's a lot of parentheses, so you just want to be careful that you're keeping track of everything. So we evaluated this integral to be here. Sorry, it got a little messy. This guy, we didn't have to do anything to, so he's going to still be there. And now here we can see we don't have any integrals left, so we're basically done. All we have to do is put this back in with this part here, because remember we were evaluating this integral. We're going to put that answer in here, close parentheses plus c, and that's our final answer. So all we have to do is just recopy this part and put it in here. So we have x times 2/5 times x minus 5 to the 5/2 minus, I'm just going to multiply these two fractions together. So we multiply across the top, we get 4, across the bottom we get 35. So 4 times 35, or 4 over 35, times x minus 5 to the 7/2. And we can go ahead and close these brackets, and plus c to have this whole thing be our final answer. So when you're doing a problem like this, it's important to make sure you keep your work neat, because there's a lot of u substitution and integration by parts going on, so you want to make sure you do your integration by parts separately. We got a little bit messy down here at the bottom, but you just want to keep track of what is actually part of your answer. And we can see in our final answer we don't have any integrals left, so we are all set. And that's it. This is your answer. Also be careful plugging this in on WebAssign. Just keep track of your parentheses, make sure you close all your parentheses, put all your fractions in parentheses, and keep track of stuff like that. But you guys should be all good with this. Alright? Good luck!